Hi guys, welcome back. Today we will be talking about measuring standalone risk using the statistical techniques. So before we begin this lecture, we should start by discussing the definition of risk. Risk is the likelihood of an outcome to deviate from expectation. So to put it visually, we have the following illustration. So as you can see in this 4-year period, note that the expected stock price of this hypothetical company is shown here. Year 0, year 1, year 2, and year 3. So the trend is going upward. This is the expected movement of the stock price. However, the expectation is not necessarily what's going to happen in reality. In reality, the stock price can go lower, such as this case. We have here the worst case scenario. Or it can be higher. So this is the best case scenario in this illustration. So in other words, what we expect is not necessarily what will happen. There may be an upward or a downward deviation. And this is what we call risk. But nevertheless, we are going to assume that we generally do not want risk. Yes, there can be an upside or a downside, but the general consensus is we do not want risk. So, how do we measure risk? We have the following technique called the standard deviation. The standard deviation is a statistical measure of how scattered the possible outcomes are from the expectation. Mathematically, it is calculated as the square root of the variance. So to illustrate what this standard deviation means, imagine a bell curve like this. So you have the following mean, and of course, what will actually happen may be different. So it can go higher or lower. So if you are going to put it in this way, we have the mean, the expected rate of return. What we expect will not necessarily be the actual event. It can go lower or higher than expected. So to illustrate, let's go to this sample case. Carlson Corporation's president believes that its common stocks returns will have the following probability distribution shown below. So we have the following probability of occurrence and potential return. So the probability that the potential return would be 30% is 30%. The probability that it will be only 8%, 40%. And the worst case scenario, returns would be at negative 14%. There's a 30% probability of occurrence. So how are we going to calculate the standard deviation? Let's create the following table. So we will begin by calculating the expected rate of return. This can be arrived at by taking the weighted average of these possible returns, using the probability of occurrence as the weights for this average. So that would be probability times potential rate of return. 30% times 30%, that's 9%. 40% times 8%, that's 0.032. Then you have 30% times negative 14%. This is negative 0.042. Okay, so the expected rate of return is simply the sum total of such. We have 0.08 or 8%. So what is our expected rate of return? It is 8%. Now, once we have the expected rate of return, this is basically what we expect to happen. We are now going to look at what can happen. It could be a 30% return or as low as negative 14%. So we are going to calculate this deviation. So we want to know how spread out the actual results can be from the expectation of this 0.08 expected return. we're going to take the difference of the potential rate of return and the expected rate of return. So you have here 30%. It is 0.22 above expectation of 0.08. If it would be 0.08, then this is exactly as expected. There's no deviation. Then finally, it can be as low as negative 14%, which is negative 0.22 below the 8% expected rate of return. So this is basically the deviation, how the actual results can deviate from what is expected. Now that we have this, we would want to combine these three figures. Unfortunately, we cannot do so because if we are going to take the simple sum, if we're going to take the sum total of such, the positive and the negative figures will simply offset one another. So to prevent us from dealing with negative figures, what we can do is to take the square of these amounts. So the square of these amounts would include 0.22, that would be 0.0484. 0 would still be 0, and negative 0.22 will also be 0.0484. Now that we have this, we are going to take the average. So to take the average, we need to multiply each item by the probability of occurrence. So again, that's 0.30 times 0.0484. That's 0.01452. 0.40 times 0 is 0. And 0.30 times 0.0484 is also 0.01452. So the average would be the sum of such. That's 0.02904. We call this the variance or the sigma squared. Its symbol is sigma squared. The variance is 0.02904. So to arrive at the standard deviation, remember that we have arbitrarily take the squared of each deviation. We should bring this back to its unsquared form. So let's take the square root, the standard deviation or sigma. That would be 0.17041. So if we're going to look at the following probability distribution, the mean is at 0.08. So the expectation is 8% rate of return. However, how likely it is to scatter or to deviate from expectation, we have 0.17041. This is the measure of spreadness of actual results relative to the expected. So the higher the standard deviation, the wider the bell. That's obvious. And the wider the bell, the riskier the investment. So, is an investment with an expected rate of return of 8% and a standard deviation of 17.04% a good one? Well, to answer this question, we should make an evaluation which compares it with another investment. Of course, whether this is a good investment or not depends on where we are comparing it to. So to do that, let's refer to the summary. The stock of Carlson has an expected rate of return of 8% and a standard deviation of 17.04%. Let's compare this to the stock of Peterson. So the stock of Peterson has an expected rate of return of 6% and the same standard deviation, which would be considered a better stock for investment. Obviously, it would be Carlson because they have the same level of risk, both have the same standard deviation. We are going to compare which has the better expected rate of return. Here we have Carlson with 8% versus Peterson's 6%. Now we are going to compare Carlson with another investment. So we have here Jackson with an expected rate of return of also 8%, but the standard deviation is 14.08%. Which would be the better stock? Okay, that would be Jackson. So they have basically the same expected return, but Jackson has a lower standard deviation, indicating that there is less risk. Another example, we have Hudson with an expected rate of return of 6% and a standard deviation of 14.08%. This time, it will not be as straightforward as we did a while ago. The analysis will be a bit more complicated. Carlson has a higher expected rate of return, but at the same time, Carlson also has a higher standard deviation, meaning to say, Carlson is riskier than Hudson. So, which of these two stocks would be considered a better investment? To answer that question, let us introduce the concept of the coefficient of variation. The coefficient of variation is a statistical measure of risk per rate of return. So mathematically, this can be arrived at by dividing the standard deviation by the expected rate of return. This is used for comparing the risk of two investments with different expected returns. So as you can see here, Carlson has a higher rate of return, but Hudson has the lower standard deviation. So which is better? Let's calculate the coefficient of variation. So we have here for Carlson, that would be 17.04%. Divided by 8%, that would be 2.13. Hudson has a standard deviation of 14.08% and an expected return of 6%. So the coefficient of variation would be 2.34, meaning to say Carlson would be the safer investment. That means that every rate of return of Carlson carries less risk. So each percentage point of return for Carlson would only carry 2.13 standard deviations, while Hudson's percentage rate of return would carry 2.34, making now the two investments comparable for assessment. So that would be it for today. So we basically measured risk in a standalone basis. Now, if we're going to put investments in a basket full of other investments, we call it a portfolio. The measurement of risk in a portfolio would be a bit different. It would be dealt with by another technique called the capital asset pricing model, which is going to be discussed in a separate video. So please like, share, and subscribe if this has been helpful to you.